This lesson, we're going to be analysing the three trigonometric functions, sine, cosine, and tangent. And in this lesson, we're going to be looking at creating the graphs of these trigonometric functions. Let's jump right in. So, trigonometric functions. So when we're working with right angle triangles, we use the three functions sine, cosine, and tangent. And you've used these for a couple of lessons now, but it's very what they actually mean is often missed in school. So we're just going to just quickly talk about what they are. So the sine of an angle, so we'll call that S. The sine of an angle is the ratio of the opposite side to the hypotenuse side of a right angle triangle. And we can already see here we've got SOH, and this is starting to look like the SOHCAHTOA, okay? And then the cosine of an angle, we'll call that C, is the ratio of the adjacent side to its hypotenuse. Again, we've got CAH, that's the K of SOHCAHTOA. And the tangent of an angle, we'll call that T, that is the ratio of the opposite side to the adjacent side, A. So what we've actually got here through these definitions, this is how we have created SOHCAHTOA, okay? And if you remember, SOHCAHTOA is the maths that we do to figure out either a missing angle when we know two sides of a right angle triangle, or to find a missing side of a right angle triangle when we know an angle and one side. Okay, so let's jump into some graphs. So first we're going to look at the sine graph, okay? And when we draw the sine graph, it is represented by the function y equals sine of x, okay? And first of all, we're just going to be plotting a point every 90 degrees, okay? So for example, we're going to find out what y is when sine is 0, sine is 90, sine is 180, etc. So when we draw our table, this is the table that we get. So x is our initial angle, and y is sine of that angle, okay? So I started from minus 360, and I go all the way through to positive 360, okay? And if we just look at the numbers, we can see that at minus 360, we're at 0. We then go up to 1, then back to 0, down to minus 1, up to 0 again, up to 1, back down to 0, down to minus 1, and up to 0. So if you can sort of visualize this, it looks like our coordinates are going up, then down, and they're going to zigzag up and down. So let's have a look at the graph. So just like you might have imagined, we have got a zigzagging looking graph, okay? So we've curved the lines off here, but if we only plotted points every 90 degrees like we've done here, we wouldn't, you should always know to round off your curves, but it looks like quite sharp zigzags on this curve, okay? So let's plot the points now with every 45 degrees, okay? So every 45 degrees, we're gonna place a new point on our graphs. Okay, so we've done that now, and I've kept the table the same. I haven't drawn a table for these new coordinates, but we can see now that rather than a zigzag, it's actually looking to be a much smoother curve, okay? Now let's have a look if I plot the points every 15 degrees. So plotting a point every 15 degrees doesn't actually change the graph that much. We can now see we've clearly got a nice wave pattern here, okay? And then the final graph is just going to be plotting a point on every degree, okay? So this graph, we pretty much knew the shape of this graph after plotting a point every 45 degrees, okay? But this just shows that it is a constant repeating wave pattern, okay? So how can we summarize a sine graph? Let's talk about the features of a sine graph. So a sine graph is represented as a wave. So as we can see here, it looks like waves in the ocean. So we can see that it rises, it falls, it rises, it falls, and it rises, just like the waves in a sea, okay? So we say it's represented as a wave. We say that this graph has a periodicity of 360 degrees. Now, what that means is if I was to block off the first 360 here, so minus 360 to 0, we can see it goes up, down all the way, and then up halfway again. And then the next 360, it goes up, down all the way, and up halfway again. And these two are exactly the same. The first 360 and the second 360 are exactly the same, okay? So what we say it repeats every 360 degrees, but the fancy word for that is periodicity. We also can say that this graph has an amplitude of 1, meaning the furthest distance away from the x-axis is 1. So if we take this point here, how far away is it from the x-axis? Well, if we look at the y-axis there, it is 1 away. And if we go on the dip, how far is that away from the x-axis? Well, it is -1, but it's still 1 unit away, okay? So we still say it's 1 unit away, okay? So it's an amplitude of 1. And then this might help you to remember when you're drawing a sine graph. The graph starts, so to speak, at 0. So when sine is 0, when the angle is 0, sine of 0 is also 0, okay? And apart from that, there's 3 relatively important sine values that you should try and remember, okay? And that is the starting value of sine. So sine of 0 equals 0. Sine of 30 equals 0.5. That's the only value of sine, apart from sine 90, where it's not a load of randomly appearing decimal numbers. And sine of 90 is 1. Okay, so those are the 3 important sine values of sine, okay? Let's have a look at the cosine graph. So again, we're going to plot a point every 90 degrees for the cosine graph, except the function this time is y equals cos of x, okay? So let's draw our table. So here's our table. Now you've probably noticed, or just by glancing at the table, this looks very similar to our sine graph. We've got 1 to 0 to -1 to 0 to 1. It looks like it's just going to be a zigzagging graph again. Well, let's see what the graph tells us. And if we look at the graph, it actually looks very similar to the sine graph, okay? It looks like it's zigzagging, it's repeating itself. So yeah, this cosine graph is going to look very similar to the sine graph, I think. Now let's plot a point every 45 degrees, see if that changes it at all. Just like the sine graph, rather than it being a sharp zigzag, all the curves are being slowly rounded off, okay? So we're getting a nice smooth graph here. Let's plot a point every 15 degrees. Okay, looking very similar to the 45 degree. I plot a point every 45 degrees now. We're getting a nice smooth wave now. Let's do the final graph where we plot a point on every degree. Brilliant. So we've got a nice smooth wavy looking graph, okay? That looks very similar to the sine graph, okay? And we will come to that similarity in a bit, okay? But for now, let's talk about the summary of the cosine graph. So, like the sine graph, it is represented as a wave. So it's got rises and falls, okay? So just like a wave. Also like the sine graph, it has a periodicity of 360 degrees. So if we look in the first 360, we've almost got a V shape. And if we look in the second 360 degrees, we've got another V shape, okay? So because it repeats every 360 degrees, we say it has a periodicity of 360 degrees. Again, like the sine graph, it has an amplitude of 1. The highest point is 1. That matches up quite nicely there. And the lowest point is also 1 unit away from the x-axis, okay? So that's why we call the amplitude. It's the amplitude of 1. Now, unlike the sine graph, if we were to find out cos of 0, to find the start of the graph, it actually starts at 1. Whereas sine of 0 started at 0, okay? So that's one of the only differences between the cos and the sine graph, okay? And we're going to look at that in a bit more detail on the next slide. But for now, there's 3 important cosine values that you should try to remember, okay? And those are cos of 0 equals 1. So that's the start point of the graph, if you will. Cos of 60 is 0.5 this time. So that's any other value of cos will give you a fairly intimidating decimal number. And then cos of 90 is naught. Okay, so cos of 1 is at 0, cos of 60 is at 0.5, and cos of 1 is at 90. Sorry, cos of 90 is at 0. Okay. Now let's have a look at let's compare the sine and cosine graphs. So, just like we said before, they're both represented as wave functions. They both have a periodicity of 360 degrees. They both have an amplitude of 1. But the difference between the sine and the cosine graph we say is that the cosine graph has been shifted back 90 degrees, if you will. Okay, so when the sine, which is the green graph, when that is at 1, it is 90 degrees ahead of cos when it equals 1. So when cos is 0, it's 1, but when sine is 90, it's 1. Okay, so we say that the cosine graph has been shifted back slightly from sine. Okay, and another way to remember the difference when you're asked to draw graphs between sine and cos, because they look so similar, it's very hard to remember any easy way to differentiate them. But one method you could do this is if you were to draw the graphs from 0 to 360, sine looks like an N. Let me just get a highlighter, show you the color now. Sine looks like an N shape, so it goes up, it goes down, and it goes up. It looks like a slightly tilted, squished N, okay? And the cosine graph looks like a V, okay? So between 0 and 360 degrees, sine looks like an N that's been squished, and cosine looks like a V, okay? So that's one way of remembering the difference between the sine and the cosine graphs when you're drawing them, okay? Or you just think of the starting point for the two graphs. For sine, that starting point was 0, and for cosine, the starting point was 1, okay? Now let's have a look at the tangent graph. So just like sine and cos, we're going to plot a point. First of all, we're going to plot a point for these graphs, for this graph, every 90 degrees, okay? So here's the table for that. Now this table looks very odd, okay? So we've got 0 to start with, that's fine, but then every 180 degrees after minus 270, we've got an undefined value. Now, the later graphs will make this clear, but basically an undefined value in maths means that there is no solution to this problem. If you type in tan, for example, if you type in tan 90 into a calculator, it will just say error and it won't give you an answer, okay? And the reason behind that is essentially you're trying to divide by 0, but that's for another lesson, okay? So let's have a look at what this graph produces. So currently, we're not actually able to draw any lines on this graph because we don't know where the lines would be going. You could argue that you could draw a line straight through all of these, but that's not the case because these points are undefined. There is no value there, so the line definitely can't go through there. So we're going to need a few more points to help us out. So let's plot a point every 45 degrees. Now this looks slightly more helpful, if not slightly more confusing at the same time. So what we've got here is some steep diagonal lines going up and to the right, okay? Now this still isn't very useful to us. It's still quite complicated. So let's plot a point every 15 degrees. Okay, still looks a bit interesting, but we can actually see now there's actually a slight curve in these graphs. The lines are actually flexing slightly, so they're not dead straight lines. As they get higher up the graph, they get steeper, and as they get, if we follow this line here, the higher you get, the steeper it gets, and the lower you get, the steeper it gets again, but it gets slightly shallower in the middle, okay? So I'll tell you what would make this, to tell you what help you visualize this. I'm actually going to zoom out the graph, okay? So currently the y-axis is 1 to minus 1, okay? Now let's change that. So it's to 5 and to minus 5. Let's see if that helps. Okay, so we can definitely see that we've got a curvy line happening now. And now we can really see the higher up the graph it gets, the steeper it gets. It then shallows off in the middle, then it gets steeper again towards the end, okay? Now, but this still doesn't really explain our undefined values at 90 and 270 degrees, say. So let's have a look at the last graph where we plot a point every 1 degree And I'm also going to increase the y-axis. So rather than it being from 5 to -5, I'm going to increase it to 10 to -10, okay? So let's have a look at this graph. So here is what the final tangent graph looks like, okay? And hopefully now you can all get a better idea of how we are getting these undefined numbers now, okay? So like we've seen in the earlier graphs, in the center of the graph, or closer to the x-axis, the graph is relatively shallow, okay? But as the graph increases, it gets exponentially steeper, okay? So it's an exponential growth, okay? And if you were to draw this graph, if I was to extend this, it's not a very straight line, but if that red line was the y-axis, and I was to continue drawing this line would get infinitely close, but it would never actually touch it would never actually touch x equals -90, okay? Because when the angle is -90, you will get an undefined value, okay? So these lines will get infinitely close to the -90 on the x-axis, but it will never actually touch it, okay? So let's have a look at the summary for the tangent graph. So this graph very much isn't a wave. It is very different to the last few graphs that we've looked at. But this graph, we can say it is a periodicity of 180 degrees. And what that means is this graph repeats every 180 degrees. So if I draw a line from -90 to 90 degrees, I can see it rises steeply, it flattens off, and it gets steep again. If I draw another 180 degrees along, I draw another line going down. It's steep, it shallows off, and it gets steeper again. And this pattern will repeat every 180 degrees, okay? And then like we said before, if we start at 0, if we start at tan of 0, which also happens to be 0, so that's the start of the graph, which is very handy. The graph has an exponential increase towards 90 degrees, so this line will get steeper and steeper and steeper all the way up to 90 degrees. And if we go the other way, it is an exponential decrease. We get steeper and steeper and steeper all the way to -90 degrees. But the value at plus or -90 degrees is undefined. So there is no value for tan of 90 or tan -90. And then the final thing then now is just we've got our important tangent values. Okay, so these are just worth remembering. So the start of our tan graph, if you will, tan of 0, that is 0, which is there. Now tan of 45 equals 1. This is the only value of tan that isn't 0 or 90. That gives you a nice easy value, okay? And that would be 45 degrees, that would be somewhere there, okay? So tan of angle 45 equals 1. And then the other just interesting one to note is that tan of 90 is undefined. There is no value for tan of 90, okay? And that is the tangent graph. So that's it. Those are the 3 trigonometric graphs, okay? You will have to learn the shapes and forms of these, okay? And we're going to do some questions on those in the next lesson, okay? We're going to ask you some questions about the 3 graphs, and we're going to do some algebra with them as well, okay? So great work, guys. Thank you for listening, and I'll see you next lesson. Bye now.